Now in example 7, we're trying to find the domain of g of x, where g of x is equal to square root of x squared minus 4 plus the square root of x plus 2. So this is going to be a more complicated example of what we did in the last video. So make sure you check that video out first before we proceed to this one, because this is going to probably blow your mind. And I hope I can explain it properly in a way that you'll understand it. But the process is going to work exactly the same as the previous example. We want to find the domain of this guy and the domain of this guy separately, and then combine them on a number line and figure out where their domains intersect. All right? So we have to first find the domain of this. We want the set of all x values that make the inside of this radical non-negative, meaning we want the inside greater than or equal to 0. Meaning x squared minus 4 has to be greater than or equal to 0. Okay? Well, what does that imply? Adding 4 to both sides, that implies x squared is equal to, less than or greater than or equal to 4. All right? So now I'm trying to isolate x, trying to get x by itself so I know what x values I can plug into this thing. So what I'm going to do is take the square root of both sides. So what does that imply? We've got to be very careful here, because now I have a square root of x squared. By definition, that is equal to absolute value of x. All right? And square root of 4, we're just looking at the positive square root of 4, because when you take square roots, by definition, that is going to be the positive square root. So that's greater than or equal to, square root of 4 is 2. So this is saying that the set of all x values that I can plug into this without getting square roots of negatives is whenever absolute value of x is greater than or equal to 2. So meaning if I plug in negative 300,000, take its absolute value, is that bigger than or equal to 2? Yes. So I can plug in negative 300,000. All right? I can plug in negative 5 million because the absolute value is greater than or equal to 2. Similarly, I can plug in positive 5 bajillion if I wanted to, because its absolute value is greater than or equal to 2. All right? So what does this mean? This implies that as long as x is greater than or equal to 2, or x is less than or equal to minus 2, the absolute value will be bigger than or equal to 2. That's what this means here. Okay? So this right here is the domain. This is the set of all possible x values I can plug into this without getting square roots of negatives. Okay? You can plug in some of these values for yourself here. Plug in, say, minus 2, and you'll see that you get square root of 0, which is perfectly fine. You can plug in minus 3, also perfectly fine. All right? So this is the domain of this. Now we need to find the domain of this guy. Let's do that in a different color. Let's do that in blue. So we need to find the domain of that. As before, we want to make sure that the inside of this radical is greater than or equal to 0. So we have x plus 2 greater than or equal to 0. But what does that imply? Subtracting 2 from both sides, that means that x is greater than or equal to minus 2. All right, so far so good. And this is the domain, by the way, of this guy. So in order for us to find the domain of this entire thing, we need to find the set of x values that work for both. How do we do that? Number line. So I'll draw a number line here. Nice big long number line. Put a 0 here at the center. 1, 2, 3, 4, 5, etc. Minus 1, minus 2, minus 3, minus 4, minus 5. And so on and so forth. Okay, first thing we're going to do, I'll work in reverse. Let's look at the domain of this part first. I want to find the domain of this. So x can be greater than or equal to minus 2. So I'll put a square bracket at minus 2 here, and then shade everything above it, because x can be greater than or equal to minus 2. Okay, so that handles the domain of this. Now I need to handle the domain of the second part. So this is saying that the domain of this is when x is greater than or equal to 2, or x is less than or equal to minus 2. So let's handle this part first. X is greater than or equal to 2, put a square bracket there, shade that in. So that handles that part. How about this? X can be also less than or equal to minus 2. So put a square bracket here. Notice that they intersect at minus 2. And then x can be anything less than that. All right, so remember, the domain of the entire function is where the domains of the individual parts overlap, okay? So where do the domains overlap? From 2 onward, and precisely at minus 2, because we have a square bracket overlapping a square bracket. Okay, so the domain of the entire thing is going to be as follows. Domain of G is equal to, okay, well, it's not going to be anything less than negative 2 because that's not where they overlap. So, and it's not going to be anything slightly, even slightly greater than minus 2. So it's going to be minus 2, just minus 2, no interval here, union, okay, 2 onward. So we have 2 to infinity, okay? And we include 2 in this case. So we're saying set including minus 2, just minus 2, so we have to put in curly braces, or x is greater than or equal to 2. That's basically what this is saying. Okay? Another way of writing this, you could write the domain is x is equal to 2, or x is greater than or equal to 2. So x is equal to minus 2, or x is greater than or equal to 2. Either one of these is a perfectly reasonable answer. We're just looking for the set of all x values that I can plug into this safely. Okay, this is the complicated way of writing it. This is the more intuitive way of writing it. And they say the exact same thing. All right, so with that, this example is done. And we'll move on to difficulty 5 problems next, where we're looking at similar cases where we have to look at 2 separate parts of a function to find the domain of the entire thing. So I'll see you in the next one.